All right, so we're now recording. This is test 4B, spring of 2023, spring semester. We've already gone over all these problems in class, so this should just be a nice wrap up. Throw in a couple of Easter eggs and we'll call it a night. Now, I know I have not put the screenshots up from the day, like the history screenshots and all. I will do that after this. Just it's been going and blowing all day. I've not had a chance to stop. So anyway, that'll get up there. This recording should be up by 10, I would think, at the latest. And then the screenshots for the day should be up by 11:30 p.m. tonight. All right. So normally I kind of work through some of this, but and I might do some of that, but this also acts as a video key for those of you that yeah, we are recording. All right, so I have the chat on if you want to ask a question through chat, or if you want to turn your microphone on at any point and stop me, that's fine too. All right, so we start off with these two. Will there be multiple choice on the test? Maybe. I haven't finished writing it. I've written about 2/3 of it. And sometimes I have a little space filler. You know, I'll stick a multiple choice in there. But physics multiple choice are no walk in the park, because there's so many little, you got to really know your stuff. I'm just warning you, if it is, it's going to be, don't jump on the first answer. I'm not trying to fool you, but I guess multiple choice by its nature tries to fool you. I don't really like multiple choice. Anyway, those are a couple of example problems that you might get multiple choice. Let's keep going though. All right, so we get to this one. Now, here's an Easter egg for you. I was not going to put this on the test. And then I changed my mind. Let's put it that way. Now, you're not going to have to find the radius, okay? That's too much work, obviously. But the green, see the green part? That is the part that, if it stays on there, that's the part. I mean, it's on there right now, but it could change. I'm still working on my room, but that's the part. So this is a different kind of graph than we've been used to. It's not a kinematic graph. It doesn't involve time. It is kinematics, but it's a two-dimensional kinematics, and you interpret the time by the time interval. Like in this case, I think it says, what is it here? Here it says that it's I mean, how would we know how long it takes? Oh, there it is. So in this case, they gave you V naught at 6 meters a second. And then from there, you could interpret how much time had gone by. So there's always a way to figure out how much time. What? Elizabeth says she can't join the Zoom. Update Zoom, but it won't let me do so without the administrator's password. What? Well, password. I'll give her the, anybody know what she's talking about? I'll give her the password to the, it's ASCII. No, wait, what is it? Is it ASCII 4? Someone's giving me a yes. Is it ASCII 4? Yes, okay, ASCII 4, but I don't know if that's going to get her on. Oh, Evan's helping her. Click on the join with browser thing. Okay, Evan, I hope you can help her. All right. Thank you, Evan. Yeah, so keep open your group me, keep open the chat, keep it all open. Anyway, so there's enough information. The one I've written, if it ends up on there, is not quite like this. It is two-dimensional, okay? It is a type 1 projectile motion, okay? It isn't on this planet, it's on another planet. It's actually on a planet with a gravity greater than Earth. I'll say that much, give you a ballpark figure where you're going to be on your answer. But I don't think that I gave you the same kind of information. You can find, gave enough information where you can find out. I think I gave you like the time interval, okay? Like it's what are like 0.2 seconds between dots kind of thing. So that's probably enough hints, but there's a real good shot. I'd say it's about an 85% chance this is going to make it onto the test on Thursday. One like this. So there's Easter egg number 1. You know how much I love these problems, only because I know what's coming in the next few weeks when we get into, this is how we'll kind of end packet 5 is with free bodies and with head to tail, free body going back and forth. So crucial to your understanding of physics. So yeah, certainly expect to see one like this on there, and you all are pretty daggone good at this. As a class, I think I have high hopes that you will understand this better than any class I've ever had. I like to go out on top, and I'm going out with you guys. You all are the best so far, and I'm not just saying that. You prove it every time you take a test. Now, be advised, though, that you probably will have to come up with the, using your ruler, and there's a plus or minus on this. If you said, I'll take like on the kilonewtons, I'll take between 18 and 22. On the degrees, I'll take between 23 and 29. Probably more than that, probably even 22 and 30, because, I mean, there's going to be some error here and there. I will say this much, though. It's not a balloon, okay? I'll go ahead and give you this Easter egg. It is, and I'm pretty sure this will stay on there, it is a truck going up or down a hill, a truck going up or down an incline. So if you want to practice think to yourself, well, what forces would be acting on a truck? I mean, obviously it's weight, air drag, if it's going fast enough. There'll be some road friction. What else are you going to have? Contact with the road. Hey, by the way, contact with the road is called the normal force. And the reason why it's called normal force is it's always perpendicular to the contact. And normal is an old math term, which means perpendicular. If it's going up the road, it's going up the hill, it's going to have some type of propulsion, force of propulsion. Now, I'm not expecting you to draw the free body diagram. I'm going to draw the free body diagram. You're going to do what you do here. You manipulate it to see how fast it's going, or see what the overall force is, okay? Not force of propulsion, the summation of forces, like we did here. But I'm saying it will not be a balloon this time. Okay, that's enough of a hint for that one. Type 1 projectile motion, folks, it doesn't get any easier than this. And this is why you need to speed your process up. You need to have you need to kind of have those reference sheets, not memorized, but at least know where to find things. Like this one, you find the flow chart, right? And then you can you got to be real careful on projectile motion. You got to use the right equation for the right situation. And the flow chart, this is the chart, this is the branch on the left, which is all type 1 projectile motion. So yeah, so that's what I used. When in doubt, you can always use the blue quad to find time, okay? It will not let you down. If it's a free fall, which projectile motion is free fall, it's free fall on a conveyor belt. But blue quad will always find time. But here I'm using a shortcut. Yeah, that T is equal to -2 delta Y over G is a type 1 projectile motion shortcut. So you hope there's a problem like this, because it's fairly routine, fairly simple to do. Number 6. Okay, so here's another Easter egg. There'll be one like number 6, or like the other one, where he's coming off a cliff at an angle, one or the other. There'll be one that involves land, orange equations, then either type 1 or type 2B. I really can't do type 2A. So it's either type 1 or type 2B projectile motion. Now, in class, like with the clip, we'll get to the clip. Here it's just, it's orange. Orange work is the roof work, the work of the land. That's orange equations. Usually third orange, right? You're trying to find the final velocity. Then the projectile motion, you have the red part, that's horizontal. You have the blue part, that's vertical. And normally you use the, on a test, I don't like to throw you a lot of curveballs because this stuff's hard enough. Maybe on a take home, but on an in-class test, I'm trying to reward the student who is putting in the effort. There's nothing more frustrating, believe me, as a student, than to put all this effort into trying to learn, the homework or the take-home test, and then the professor or teacher, in my case, throws you a wild, crazy, which happens all the time in college. I can throw you a curveball, but that can only be 10% or 30 points. All right, so most likely it's going to be what you're seeing on take home. Let's keep going. I'm blowing on past these. If you want me to stop and talk about any particular part of this, I'm trying to get you out of here early tonight. Been a long day for all of us. All right, number 7, that's all type 2A. I didn't need the range equation here because they weren't asking about the X. Notice I didn't use any red equation. I didn't even care about the X because time is all I really needed. I suppose you could have maybe found the range. Yes. Here's another way to do it. It's the long way, but you could have found the range, and because it's type 2A, you could have you could have found the range and then realized that at the apex on a type 2A is halfway, taken the range, cut it in half. From there, they get a delta X. V naught X. Yeah, that's stupid. Why would you want to do that? That would give you time and then plug that in. That's really not, I'm not saying stupid. I don't mean to say stupid. I'm the king of stupid as far as solving problems the dumb way, the long involved. And that's why I like shortcuts so much, even though they're dangerous. But this one's no shortcut. It's just using third blue, knowing that the apex velocity is 0, okay, in the Y, not in the X. But I don't care what's going on in the X. I only care about the Y here. I could get it. If I can get it with the third blue, I ain't going to worry about nothing else. Okay, so that's number 7. I showed you my hops in class. I'm a little below Josh Giddy. I can get up there 4 or 5 inches. Jumping, that is. Number 8. This is that tax situation I talked about. The price you pay. All right, so because, gravity always employs a tax, you would like to just keep going forever and ever, but Newton would say that gravity is employing a tax, and I guess Einstein would as well. Einstein would say you are going in a straight line. It's just that space-time is curved, and so you can't do anything about it. Yeah. So anyway, the whole point of this problem is to show you that there is a physical significance to every aspect of the second blue, kind of the anchor blue equation. And that's where I'm showing here. And then I threw in the red. That's, total delta X sub R range. In this case is just V naught cosine theta times tau, total time. All right. Not seeing any chats up there. So everybody seems to be either asleep or okay with what's going on here. Remember I told you there won't be any more derivations on tests, but what could happen, there's one on there now, but I may run out of room. What could happen is that I ask you like a question about the derivation, you know, like how did we get rid of time on the range equation derivation? Well, we got rid of time because we substituted in, you know, you see the blue there, we substituted in tau for 2v naught sine theta g over g, and then substitute that in. Those kind of questions. Might ask you, what is the double angle formula in trig? Very, very important formula, but you have this on a reference sheet if you know where to look. Okay. Still recording. Number 10. One of my favorite kind of equations, hint, hint. This is a favorite of mine because because you're using range equation. It's legal here. This is not type 2B. This is not type 1. It is type 2A. Check. And if that's the case, then I would go for the range equation if I was you. It just speeds things up. Like you don't have to find time and then plug time back in. You can just do it all in one equation. This still throws students because they get all bogged down in the inverse sign, and then they divide by 2 at the wrong time. It's the whole thing divided by 2. And by the way, pumpkin chunking is something you'll do in college. If you're you build these catapults. If you're in engineering, you build these catapults and you chunk pumpkins. It's kind of fun. Around October, it's kind of fun. All right, so we got 15 degrees there. Ah, yes, the gold standard. Will there be a gold standard on the test? The answer is definitive. Yes, yes, there will be one on the test. I will give you it. There's an Easter egg. It will involve the range equation. Okay, not exactly like this, but it will involve the range equation. Let's just say this is probably a good one to practice on. Still no questions. Okay, okay. Little things to watch out for. Hey, for goodness sakes, don't leave it blank. If this is on there, and I think it's worth like 50 points, you know, one problem, that's 25 stamps to put it in perspective. So it's worth your while. You want to get every stinking point out of me. And the rubric will say, I give so many points for the drawing. Okay, anybody can draw something. It has to look somewhat right. I give some points for writing out the range equation and the symbols, for isolating the variable, you know. And then if you make a mistake, well, you've got some pretty, I'll try. People get this, these are rarely black, and it's not going to be black, we know now. But people usually get pretty good partial credit on these, except for those that just kind of give up and leave them blank. That's not good. You might save this one for last, just because you don't want to get bogged down in a conversion. And, you know, what I used to do is look it over. Then I first time through, I'd probably skip unit analysis. I'd skip gold standard. I'd go do what else I can do, triage, get those points. I think there's only like 7 or 8 problems on the whole test. It's not necessarily a good thing. Okay, questions on this? Okay, 12. Now we're on the next version 2, or the second part 2. So it comes down to, like I said in class, it's either going to be one like number 12 or one like number 13. Okay, not both. There's not enough room for both, not enough time for both. I like them both equally. Now, if it's one like number 12, you're going to have to plot the 5 graphs that go with it. Okay, so there's no way you're getting out of not plotting the 5 graphs, the 2 X's and the 3 Y's. That's going to happen. It's either going to happen like this, or it's going to happen like Joe off a cliff. Okay. Well, here you gotta break up your thinking into, okay, day one, I'm trying to find, using the range equation, I'm trying to find initial velocity. Day two, now it's a type 2B problem. And I got to combine the red and the blue, because I got to substitute in for time. So this is a really hard problem, no doubt about it. Watch your signs. This case, the theta, if you're launching from either from the table to the floor or the floor to the table, the good thing is theta is going to be positive. Okay. What else? Make sure you use the right G. This one happened to be metric. It could be English, in that case 32.2. We could be doing it on the moon. In that case, G is 1.67, which I would give you. Okay, those are all things I've done in the past. Okay, let's go to this one. So, like I say, it's one. Ooh, oops. Oh, whoops. Where'd that come from? Oh, I'll just show you. Stop messing around. Well, first off, that's ours. That's the one we did in class. That's the yeah, that was the one on the practice test or on the take-home test. Good grief, please. If it's this problem, you know what your graphs are basically going to look like. Please don't give me a sine wave or something. That just sends me into a big depression. So don't do that. Don't ruin my weekend. You know it's going to look like this. You know that no matter what, you know that the X will look like that. The X versus T will look like this. The VX versus T will look like that. You know that the G will look like that. Okay, and you know that the VY versus T will look like this. It'll be a negative linear slope, but this one happens to start off at a negative velocity. It might be a bow tie, right? If he's going off a ramp that has a positive angle. And this will look parabolic, negative parabolic. So that general shape. Now, one advantage, whereas if this is the problem, is that you have one of these on your reference sheets. You have one of these like this, all spelled out. It's a whole page. So so that's a big plus if this is the one I choose. I was kidding around, but this was this is last year's test. So it was black. But you know what? I rushed them through this much more than, and look how many points it's worth. 60. So, and because it's a lot of work. It'll take up a lot of time. And so I'm trying to compensate you for the amount of time it's going to take you to get through this. Yeah, I think this is from last year. It's pretty much like the one on the take home, just different numbers. I'll leave it up there if you want to take a screenshot of it or something, give you another one to practice on. What I would do if I were you, I would take a screenshot, then I would cover it up, cover up the answer, maybe print it off, cover up the answer, and try and do it, and then check versus the answer. One of the main things on this one, the land, you're just going to use your third orange, but the air, remember one of the key things is right here. That is a negative. On this right triangle, that is a negative 12.5. Okay. So because sine of a negative angle is negative, cosine doesn't matter, but sine does. So if you just draw it like that, then that maybe that helps you from making that mistake when you're trying to plug it into the quadratic formula. A lot of negatives here. Now it doesn't matter inside the radical because you're squaring the V naught Y, but it does matter whether you're using a positive or a negative delta Y, and of course it's going down below, so it's negative. Yeah, you'll only get one good time. Once again, though, it's a different problem, but still, see, the general shape of the graph is still the same. Okay. Oh, Evan's got a question. Can we go over the Y graph and how you draw it on a problem like number 13? Yeah. So that's a good question. Thank you for that. Now, V naught Y is, like in this case, on the one from the take-home test, was negative 14.4. And I got that from just using trig, knowing that from the final velocities, the initial velocity in the air, which is 46.7 feet per second. I take that 46.7 times sine of negative 18. I should probably make that negative. It shows as negative, but in the equation is going to be negative 18. And that gives me negative 14.4. So for the Vy versus T, I start at negative 14.4, and the slope, let's get the arrow going here. The slope of this line right here is always negative G. Okay, wherever planet you're on, it's always negative G. Now the question is, then how do I go about getting this graph? Well, you assume that you're going to start at 0. I mean, you might as well. Why would you make it different? 0 is the origin, so it's going to fall below where it comes off the cliff. And then in the problem here, it happened to say 25-foot vertical cliff. I could give you enough information where you're having to figure out what that is, but that's not generally how I do it. So you would have 2 points, right? You have the 0, 0 at 0 time. And then you have the negative 25 feet. Now, you know how much time went by. You found that in the blue quad. And so I just put another dot right there. And I know it's at negative 25 feet because that was in the problem. And then that's good enough for me. Don't connect it with a straight line. You connect them with as much of a curve as you can get. Okay. See, it's a little curvy. You just got to see a little curvy. That's all. Just not straight like that. See, that's a little bit of that's part of a parabola. Okay, same thing here. See, part of a parabola, negative straight on bottom. All right, very good. Now we're on this one, and this one's also another favorite because, man, this is why there's only like 7 or 8 problems in this test, because you see each problem can be a real booger. This one's a good 3 or 4 step problem, about a 4-step problem. It's such a typical physics problem. Usually it's somebody throws a rock off a cliff, either a type 1 or throws it down, type 2B, and then the rock hits the water. And then the question is, how long after it leaves her hand, say she threw it, after it leaves her hand, how long will it take before she hears the splash? It's in every physics textbook there ever was. So that's kind of what this is. It's how long after he throws the baseball does he hear the, curse word. I always start with red. I go as far as I can in the red. And then usually I find out, oh, I need time. So then out comes the blue quad. You just got to methodically attack this. So step 1 is the red, go as far as you can. Step 2, go to time, find blue quad, find time. Okay, so we can say, I'm gonna mess this all up, but I guess I will. So this is step 1. This is step 2, find time. I don't use the other time because it says on the way up. So this is step 2. This is step 1. Then now that you have that, you're still not done. Step 3 is to multiply time times V naught X or Vx, and then that's going to give you delta X. You're still not done. So that's step 3. Step 4 then is to draw the right triangle. Okay, find out the step 4. Find out the length of the hypotenuse. Ooh, and the bad thing about this one is there's not an example on the reference sheets. I should add it. Maybe this summer I'll add it for for my all course kids. So that's step 4. Then step 5 is to take that and use Mach 1, a speed of sound. And step 6 is to then take that, add up your two times. So it's a 6-step, it's a legit 6-step problem. That's a booger. I mean, I'm trying to have mercy. I don't want to make the test every daggone hard problem we ever had. There are professors that'll do that to you. And yeah, I know. I mean, I could make it black if I had to, but so I'm not saying it's not going to be on there. I still have room. All right. Let me kill all that stuff. Let me get rid of all that. Make it look nasty. Okay, there we go. Now let's keep going. 5 is a nice break. As long as the whole point here was momentum vectors are suitcases. They have both velocity and mass hidden inside them. And so that's why you got that, even though it's 5 kilograms, it's 4 blanks because each blank is 5 kilogram meter per second. But it's 5 times 4 or 20, and then 10 times 3 or 30, and then you add the 2 up. But yeah. So you're adding up the momentums. So yeah. So and there's no angle involved, so it's not that bad. All right, that's kind of a trivial question, actually. Number 16. Now we're getting into these shouldn't be as bad after what you're going through with type 2B projectile motion. These shouldn't be too bad. They're just yellow equations, just conservation of momentum, bullets and blocks. Like I said in class, on the one in class, the block was sitting there, the bullet hit it, they both slid. Now the block's going to the right, the bullet's going to the right, hits it, they both slide. So what would you expect, right, on the test? Hint, hint. Okay, and there's always a bullet and block problem on tests. Now, where it gets interesting is when the block is going up a hill and the bullet's coming down the hill, but we're not going to deal with that yet. Okay. That's more in the AP physics, because then they throw in friction and it gets very messy. But we're just touching the surface in this class. 17, red dog and blue boy. Once again, this is an elastic collision. The one thing you got to worry about is right here. Make sure that if they're going to collide, they're probably going opposite directions. Red dog, blue boy could be going along and red dog comes up behind it and hits it. That way there's no negatives, but I doubt I'm going to do that to you. I want at least one negative in there to make sure you realize it. And once again, CGS system here. If you wanted to use MKS, I'm not going to complain, but it's just a lot easier in CGS. Okay, now we get to new stuff, which I'm coming around checking tomorrow, but I guess since you're here, you get to see it. Oh, okay. So here we are. I did this one a little while ago, and I don't know if I'm right. I was rushing. Somebody check me on this. Okay, so this is the hamster and the Super Bowl. Now, I got 149, and I didn't get a chance to vet this with you. So let me show you my logic, and if you find a mistake, then certainly we can fix it. But first thing I wanted to do was I wanted to find out how fast that hamster ball hit the ground. And so the mass doesn't matter. Remember this? We drop a basketball, we drop a tennis ball, it doesn't matter, drop a grand piano. As long as air drag's not involved, they're going to hit the ground with the same V final. So the mass doesn't matter in blue kinematics, free fall. So I just used the third blue, found out V naught Y. I dropped him, initial velocity, it says here is 0. So I drop him. I didn't bring the mass into it. And then I got a final velocity of 6.26 or 6.3, maybe a little too much rounding, but no, we gotta go 3 siggy, 6.26. Now that's final velocity. It's actually, okay, so final velocity, this is one thing that we're gonna talk about tomorrow, but final velocity of the ball hitting the ground, it hit it negative, and then you have to make the assumption, because you have no choice, you have to make the assumption here that it's a perfectly elastic collision with the ground, so that when it bounces on the ground, it bounces back up with the same velocity. I don't know how else you could do this. So that's an assumption, but you have to make it because so the initial velocity of the balloon bounce, assuming no kinetic energy is lost, which we know is definitely an approximation. But the ball then must come off the ground with the same velocity hit the ground, the ball hamster. Because when the instant it comes off, this is basically a recoil with initial velocity. So I have but my second part of my problem here is I have the mass of the hamster plus the mass of the ball starts off together for the first microsecond, and then they're going to separate, okay, because they're different masses. So that's where I got this equation, and you can look that over and correct me if my math is wrong. I was busy doing 2 or 3 things at the same time, so I'm famous for making dumb mistakes. So we have here, we have the combined mass, okay, at that speed, and then they split apart. There's the hamster, 1/8 of a kilogram, 125 grams. I'm using MKS system. Times its velocity plus the mass of the ball times its velocity. And I gave you its velocity, right? Somewhere I gave you its velocity at 1.8 meters a second is how fast the ball bounces off the ground. Then I just solved for the velocity of the hamster, the final velocity of the hamster after collision. Hamster takes off, right? And I got 100. That seems, I felt sorry for that hamster, but 149 meters a second. Questions? Anybody else get the same thing? Thumbs up if you got the same thing. Okay, Rafa did. Anybody else? Same thing I got, 149. Is Rafa and me the only two that worked this problem? 149. Oh, here we go. Ben says, yeah. Charter says, how do we find the delta? What? Delta Y? Is that asked? Was that asked? How? Oh. Good point, Stamp there. Sorry, I never answered the question. Okay. How high will a hamster fly? Well, to find my delta Y, that's a great question because I asked it and I never answered it. I guess I'll go back to blue kinematics. V final squared equals V naught squared minus 2G delta Y. And then this is basically green because at the apex, V apex squared equals 0. Once the hamster finally reaches 0, all the taxes paid from gravity would equal 149. That's why you guys weren't answering. Meters per second squared minus 2 times 9.81 times delta Y, and then solve for delta Y. So here we go. I bet it's pretty high. Now there's no air drag here, so it's a little artificially high, but that poor hamster. 149 squared. Oh, shoot. 149 squared divided by 19.6. Oh, that hamster, he went delta Y. Is that right? Wow. Okay, that hamster went 1.13 kilometers. Yeah. So probably would hit the ceiling, I hate to say, but let's say we did it outside. Yeah. And so Ben got that. Yeah, 1.13 kilometers high. Okay. You know, I'm making up numbers. I mean, obviously it's a little crazy, but if it had that kind of elasticity, I guess that might happen. Okay. Last one. This, once again, I might have made a mistake. I was talking to the insurance man. This is going on. Nicholas and Xavier, are we agreeing with this? The mythical Shargo says, yeah, I like that. Turn this heater off. Okay, Megan, I got a couple of good thumbs up there. Give me one more thumbs up and I'll feel good about it. Oh, okay, Rafa, there's nothing really spectacularly. Oh, okay, so will this be on the test? Yes. I'm giving you an emphatic yes. This is always on the test. This 4-panel cartoon will be on the test. Now, how would I change it? I've had it every possible way. Nicholas or whoever it is could be going to the left, going away, and then throws the ball, okay, or the rock or whatever it is. Whereas the other person's coming, they could be going opposite directions. They could be coming together, but they could be going opposite directions. And then the other thing is, you got to watch that speed. Is it relative to the thrower? Is it relative to the ground? Okay. It's one or the other. I mean, I'm not going to make it relative to the other person. That's just stupid. So it's either relative to the thrower or it's relative to the ground. I have not written this one yet, but I know it's going to be on there. And it won't be like last year. There will definitely be some negative involved. Like here, you had to say that, Xavier is going -3, okay? Or else, like they're not all going the same direction. Now, I've had it where it's turned the person around and sent them back the other way. That's happened. In fact, after I get done here and I do screenshots for the day, I'll probably finish writing the test. So, yeah, I'll write. I haven't written this problem yet either, so I got to do this one. But that's the kind of things to watch out for. Who's it relative to? And there is one of these on the reference sheets. The last, one of the last things to look at. Make sure you check out that reference sheet one. Okay. Will you cut points for not coloring? Yeah, probably. I will probably, because you have to color. I think coloring is important here. Only, I know you're going, I don't like to color, but you should have a couple color pencils. Yeah, I mean, you don't need to bring the colors down to the equation like I did, but within the drawing, you should be able to separate things out. Yeah, probably have to have some coloring going on. They lose some points if you don't. Okay. Anything else? That does the whole thing. I'm going to go right now and I will record. I've recorded this. I'll go ahead and set this, put this on YouTube. It takes a little while to transfer over. And then I will put screenshots up and then I will finish writing the test. And then I'm going to bed. Rafael says, could you go back to 18? That's 18. Yeah. All right. So everyone's free to go. I will do overtime now if you want to stick around. I'll leave the recording on in case you ask a question, but that's it for the official. I appreciate all of, look at these people, 2, 4, 6, 8, 10, 12, 14, 16, 18 students showed up. That's pretty good. I'm happy with that. So watch for the recording. And oh, more questions. Ben says, after that, can we go back to 17? Okay. Okay. So Rafa, you okay on 18? Take a screenshot if you want. Now 17, 17 with Red Dog and Blue Boy and CGS. Take a screenshot. All right. People are checking out. People are waiting around to see if I sing the Star Spangled Banner. I've already mangled that one pretty good. Anything else? Anybody else? Okay, Rafa says, I may have an answer for the initial velocity. Oh, initial velocity of the asteroids? Oh, you mean the, oh, okay. We must have found it somewhere then for the asteroid. Oh, forgot the plus. Okay. Yeah, if you have that, that initial velocity, right, that'll do it. If you have that initial velocity, Rafa, that would be nice. I mean, it's still, I mean, the point is made. It's a huge arrow versus a tiny arrow, but I'm kind of curious. 12.4 kilometers per second. Now that sounds more realistic for the speed of a heavenly body. You know, they move incredibly fast. So that's going to make that arrow even bigger. Yeah. Now you're going to need either you're going to have to put a little dot for the dart, or you're going to have to get a really big, do it on the whiteboard. And I don't know what angle it hit it at. I don't know if it might have hit it right on, 90 degrees. That's what you would hope, right? You would hope it hit 90 degrees. That'd get the most bang for your buck. If you hit it at a 4-degree angle, then it definitely ain't going to change its direction. Hardly at all. Well, orbits are there's no such thing as a circular orbit. All orbits are elliptical. Who figured that one out? Isaac Newton. All orbits are elliptical. Yeah, it could have been near circular. Shorter says, could you go back to number 3? All right. Number 3. All right. Keep in mind, you won't have to find the asteroid's radius, but I wasn't here at that time. Yeah. Just concentrate on the green part there, finding G. It won't be the exact same equations. It's the same. Maybe you have to manipulate a little different variable. But you are finding G. The rest of this is just too much to put on a test. I mean, you take a screenshot of that if you want, but that won't be on there. That's just take-home fun. I would get run out of town if I put that on the test. All full-blown, and rightly so. Angle was about 60. Okay. Really? Okay. Well, I mean, we're not going to get 90. It'd be amazing. 60 is better than 45, I guess. It's not so bad. Okay, so I still got a lot to do tonight, so I'm gonna probably get off air here so I can get this thing on YouTube. All right. Okay, guys. We'll see you tomorrow, bright and early. See here now, over here. I want to hit the stop recording button. Okay. It's just me. Now, if I can just get off here. All right. Stop the sharing. Okay. Stop the recording. Yeah. End. Boom. End meeting.